Are you ready to jiggle, 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 jiggle?
All right, guys, so there is a standard that it's now lowering into the oven. And as you can see, there's more samples already in there that it is analyzing and heating and doing what it needs to do. And this is the way, once again, that the machine can save us time. So as those other three that were in the front row, they have been in there maybe close to 15 minutes or 10 minutes or 5 minutes, but another one has just been added. And now that process can get started with that sample or standard.
Whee! Yay! Look at me! This reminds me of the old school, you stand on the platform, put the rubber band around your waist, and just let it jiggle, 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 all that fat off. That's what I think is happening here in the sample containers. All right, there's tray 4. Over to the left, you see tray 1, tray 2, and tray 3. There's the injector down toward the bottom and the FID. The screen on the GC where we can control things on the instrument, not software, and then hydrogen generator. Gas tanks over on the left with the regulator pieces that control the flow that goes out. Auto sampler needle, and once more the oven, the Game Boy, and the computer and software that operates everything that you see on the left-hand side. All right, so as you can tell, we got to be patient a little bit for a sample to be injected, but it will eventually get injected. We just got to give it some time. Great news about auto samplers. They do this for you automatically. You do not have to be over here for any of this to take place. I'm only over here to record it and film it. That is it. So at the moment that I hit start batch, that is the time that I could have actually walked away and went to go do something else, and then come back a little bit later, hours later, and just pick up from where it has made it in the sample batches. The needle is now puncturing the top of the sample container, and it's pulling out all of the headspace or the gas that's in the vial. Now it's going to go to the detector. It injects the headspace gas sample. Now it begins to separate inside of the column of the GC. Then it's going to return back to the oven. It picks the vial up that it just injected, and it takes it back home where it found it. Oh, how sweet. And there's the auto sampler process that begins to take place. Again, injector. That is where the sample gas plug will go that has alcohol plus all the other stuff that can evaporate off. And once more, controlling the unit through the touch screen or through the software. Sample has been injected. I'm seeing a flat line. Pretty normal. It's going to stay flatlined for a little bit. Eventually, though, some signal will begin to show up on the computer screen. If it does not, I just need to zoom in a little bit more. Maybe I'm zoomed out too far, and I need to zoom in just like anything else to see a closer picture, and then I'll be able to see some signals that begin to form on the computer screen. This takes at least a minute or a little bit longer to generate some signal, depending on the flow and the heat and the way the instrument is behaving that day. But this is not uncommon, so that's exactly what I would like to see for sure. Okay? All right. Here's another video.
Okay, so we're jiggle, 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 jiggle. That's what we're doing right now, and we are getting close to the point that it's going to inject the next sample or the next standard, whatever is next in line for the auto sampler. That's what's getting ready to happen here in just a few moments. This heater, again, has more than one sample in it at a time because it does stagger those so it can process more quicker and faster. That beep always means the auto sampler is going to be doing something. So down it goes, and it is going to pull back the air plug in the sample container, the headspace vial, and it will pull back 1 milliliter, and it is sucking that up as we speak. And up it goes, and then down it goes to the injector, and now it's injecting that air plug, and that GC is now going to begin separating our alcohols from each other. It's now going to go up, and it will lower itself back down to get that container, raises it up, and it places it back in the tray where it needs to go. And then it releases it. All right, and it's just going to repeat this process over and over as we go through our 30-some samples that we need in the auto sampler. What it will do next is it will continue to heat. It will then inject our next one. It's already done that. It's going to wait 10 minutes. All of that has to process, and then it will go to the next vial and continue to inject the next one and the next one and the next one.
All right, so what you're seeing is a flat line still on the computer screen. We are past the 2-minute mark, and this is for the particular sample that we just got injected. So this is going to let me maybe have an idea of what's happening. The computer screen is just zoomed out way too far. I mean, it's like we're out in outer space and we're trying to see someone's roof of their home. It's just going to be hard to do that from out there. So we've got to zoom in a little bit in order to get a clearer picture of what's happening. This is not a big deal. I don't have to make this setting. The computer software will actually make that setting for us. And then here's another video that just kind of continues that. So more flatline. So at the end of the run, the nice thing about the software is that it will realize how close it needs to go to zoom in. So that way we've got a better understanding of what's actually happening signal-wise on the reports that we begin to print out. So I'm not too terribly concerned here. I mean, I could go over and I could manually zoom in. I just did not do that here. I don't know why. I just didn't do it. And I was distracted doing some other things maybe. Who knows? But at the same time, I know that at the end of this, I'm going to see it on the report, and hopefully it will look pretty good. And it will zoom in close enough for me to see things that I'm not necessarily seeing here. So after the run takes place, here is an image of what the signal begins to look like. So here at the 0 mark, that's 0 time, an injection was made, and that injection did include air. I mean, that was what was in the container too, right? And air is not an alcohol. It's not really a finicky component. It zooms right through the tunnel. It's so little that it doesn't get held up any at all, hardly. So we often see a disturbance that happens about 0.5 minutes with this analysis run. And that little dip that comes back up, that is just a sign that something was indeed injected. That is like a confirmation thing for us. So we're like, yeah, something's got injected. I see a little disturbance about a half of a minute. So yeah, okay, I know that something has went through. Now let's see if it actually sees it. So as I zoomed in, eventually I did do that. As I zoomed in, what we're going to see is that the flat line no longer becomes absolutely flat. So a little over 2.5 minutes, we see a signal, which is like a little hump that begins to appear, and it comes back down. And then I see another hump a little before 3.5 minutes that goes up and then it comes back down. And then I see another hump at 4.5 minutes up and then comes back down. And then I see another one at a little greater than 5.5 minutes up and comes back down. And then I see another one a little past 6 minutes, and again a little taller, a hump, and then it comes back down. So this is the idea of what a signal is supposed to look like.
All right, so what you see on the computer screen right now is our very first standard STD1A that we have ran and analyzed. A couple of things I want to mention about what you're seeing on the computer display. As you can see, there's a little bump up here at the beginning. That's normal. That's an air plug. That always comes out first. It's a very good sign that something got injected. And then after that little hump, you see a couple of other things that begin to take place.
And I will say that I misspoke, that 2.5 minutes is not really the air plug. The air plug happened a little bit earlier. I thought it was by looking at it. But then after I ran some standards and looked at more data, I realized that that was actually one of the peaks that we were after. So please ignore that. That's not the air plug.
There's a bump that's here and one that is there, one that is here, one that is there, and a huge one that's over here to the right hand side that goes up and off the chart actually. So these are the individual standards that we have ran, and they traditionally go in the order of boiling point. So what you're seeing is that acetone will normally come off first, and then you get your...
All right, so again, I'm going to misspeak during this analysis. The reason is because, again, I thought this 2.5 minutes was an air plug, and it is not. That is one of our first standards. So acetone is not 3.5 minutes. That's actually the acetone peak here, 2.5. Our methanol would come next, and our methanol would be 3.5. Our ethanol would come next, and that would be 4.5. And then what we're going to see here at after 5.5 and then 6, and then this huge one. The huge one is the propanol that we use in the lab procedure. That propanol was a very large amount. We put 1 milliliter of that sample in our sample containers. So that should be a very big peak, and that's that one. But one of these alcohols, I don't quite know which one it is. At this point, I didn't. But one of these alcohols has an impurity, and that impurity is actually showing up. So we try to use really clean methanol. We try to use really clean ethanol as well as N-propyl alcohol. But there are slight traces of impurities, and these impurities were so much that it actually had its own peak here. So I will tell you that the alcohol peak for this data set will be around 4.4 minutes. That is our alcohol peak. What I'm getting ready to explain here is all off a little bit because, again, I thought the 2.5 minute one was an air plug, but it is not. Keep that in mind.
Alcohol, 3 mixes that will come off next, and most of the time it is methanol, and then it's ethanol, and then it's the rubbing alcohol that we have in our standard set. So that's the order that they traditionally come out in. What you see over here on the right hand side of the screen that's extremely huge and big, that is our internal standard. Keep in mind, we added a lot of internal standard. It was 1 milliliter of internal standard and 0.1 milliliter of our standards. So the internal standard will be quite large, it will be fairly big, and it will come off last in our chromatogram. This is close to 8 minutes. Not quite, but close to 8 minutes here. 7.9 minutes is what the computer screen says. If I wanted to, I could take this and I could zoom in and I could enlarge those areas a little bit more. So again, you see the bump here in the beginning, that is an air plug.
No, it's not.
And then a small peak here, that's our acetone.
No.
And then that one is the signal for methanol.
Ethanol.
Then this one is the signal for ethanol.
Impurity.
That one is going to be the signal for rubbing alcohol or isopropyl alcohol. And then finally, our large one, which is here, is going to be our internal standard. Notice there's a lot of bounciness in between these peaks. That is a signal to noise ratio issue. So there is a baseline that's there. That baseline is not completely stable. It's always bouncy. That's what you're seeing. And then you're looking at something like this and say, well, what about that thing? Why isn't that a peak? Why isn't that something? Well, it could be, but these things should be 100% pure, and they're not. There's going to be contamination involved in those, and that could just be an extremely noisy baseline at that moment. So just because that is there does not mean that it's necessarily anything that we need to be concerned with. Also, keep in mind this is our lowest standard, and our lowest standard will have the lowest, smallest peaks. So we hope that as we increase our standards, they will go up and up and up and up and up. All right. So that is what we're seeing on our computer screen as we go through the process of running these standards, these samples. Blanks, of course, should not have anything at all. They should just be blanks. But that is what the signals look like on our computer. Down at the very bottom, this is a table with a lot of that data that's going to be involved. Here in the beginning is the retention time. That is how long it's taking for those particular things to come off. Here is the area. The areas we will be using for our calibration curve in Excel. And then a height table, and we never really use height for any purpose at all. We always use the area, and we always use the concentration of the standards that we have prepped.
Alright guys, so that really is the last video and the last slide for this particular portion of the lab experiment. It focused on the piece of equipment that was known as the HSGC FID system, with an auto sampler that was capable of doing the headspace injection. If I did not have the auto sampler, I want you to imagine for a minute me working in a laboratory and then having all of these sample containers, and these sample containers have to go into a hot block, and they have to be kept in there for a certain amount of time. Then I got to take them out, then I got to manually pull back on syringes, and then I got to manually inject that sample into the instrument with those syringes. It's not a very fun thing, and I have to babysit it the entire time, and that's why auto samplers are so important in today's laboratory environment. It will take over and provide me some extra time to do other stuff, so I don't have to sit there and do the monotonous chore of injecting one little sample after another after another. That's something that we don't want to do. None of us enjoy it, and you wouldn't like it either. So that is our headspace system. That's how we test for blood samples. That's how we release the alcohol from the blood sample. The oven is going to allow us to do that. That needle will pull out the gas form of that alcohol and shoot it into the machine. And then we've got to do a little bit of math work that we'll talk about in upcoming videos in order to figure out how much alcohol was in those blood samples that were submitted to the lab. Keep in mind, there were a total of 5 blood samples that we analyzed, I believe, and we did them in duplicate, so we'll get a really good idea of who's drunk and who's not.